Hi, and welcome to video 2 for section 12.1. This is the second of the 2 videos for this section. In video 12.1, we are talking about different sequences. There's a famous one that I want you guys to know, and this is called the Fibonacci sequence. So if you guys are planning to go on to other math classes after this 127 class, you're probably going to encounter this Fibonacci sequence. It's a very famous one. We have the following. So the Fibonacci sequence says this. F1 is equal to 1. F2 is equal to 1. And f of n, the nth term, is equal to f of n minus 1 plus f of n minus 2. So this is fancy notation of basically saying we're given 1 and 2, and everything after that is just the sum of the two values before it. So let's look at a few of these. So f of 3 would be what? So f of 3 minus 1 is f of 2. Plus f of 3 minus 2 is equal to 1. So that means f of 3 is just f of 2 plus f of 1, which is 1 plus 1, which is 2. So now f of 4. So that's what? That's f of 3 plus f of 2. So f of 3 is equal to 2. F of 2 is equal to 1. So f of 4 would be equal to 3. We'll do a few more here. F of 5 is what? Well, it's f of 4 plus f of 3. So f of 4, it's basically just the two numbers above it. 3 plus 2 is equal to 5. So go ahead, pause the video here, figure f of 6, f of 7, and f of 8, and stop at that point. Come on back, we'll work those through, and then we'll move on to our sigma notation. All right, welcome back. So f of 6 is what? It's f of 5 plus f of 4. So the way we have this written, it's just the two above it. 5 plus 3, which is 8. F of 7 is what? Well, it's f of 6 plus f of 5. So 8 plus 5 is 13. And lastly, f of 8 is f of 7 plus f of 6, which is 13 plus 8, which is 21. So you can see how this thing's growing in a hurry, and that's one of the features of this Fibonacci sequence is we start with 1 and 1, but as we keep adding the two numbers ahead of it, it starts to grow very rapidly. All right, so now, second part of section 12.1 has to do with our summation notation, or sometimes you'll hear it or see it written as sigma notation. So sigma notation has the following notation here. So we have the sigma sign. We have k equals 1 on the bottom, and then we have some value n at the top. So this point, so k could change. K could be 2 or 3 or 4, whatever. But whatever it is, this is where we start. We start with k is equal to 1, and this is where we end. K equals this value n. And then we have some function here. So what this means, if I have k equals 1 to n of the value a of k, the function a of k, this just means a1, and sigma is the fancy way of saying addition. So we're just adding all these terms. So when k is 1, plus when k is 2, plus when k is 3, plus all the way up until k is n. So that's what this sigma notation means. Where do we start? Where do we end? And then we have the function on which we're applying these values. So let's look at a few examples. First I want to find the sum of k equals 1 to 5 of k squared. So I'm plugging in k is 1, 2, 3, 4, and 5, and then adding all these numbers together. So we get what? Well, when k is 1, we get 1 squared. When k is 2, we get 2 squared. K is 3, 3 squared. K is 4, 4 squared. K is 5, excuse me, 5 squared. So now it's just a matter of simplifying these. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. Add all those up, you get the value of 55. Let's look at another example. Let's say we want to find the sum of I equals 5 to 10. And in this case, our function is just I. So you can see we've changed our starting position. We didn't start at 1 anymore. We started at 5. So now I is going to be 5, 6, 7, 8, 9, and 10. And we're just plugging in that value and then adding them all together. So go ahead and pause, give this one a try, come on back, and we'll work it through. All right, welcome back. So we have what? We're starting when I is 5. So that means it's 5 plus 6 when I is 6. When I is 7, it's 7 plus 8 plus 9 plus 10. And that's our ending value. We end at 10. So you add all these up and you get 45. One more example. So here we want to find I equals 1 to 6 of the function 2. So we don't have an I there. So what does that mean? Well, when I equals 1, what's the function equal to? Just 2. When I equals 2, what is the function equal to? Again, just 2. When I equals 3, it's 2. When I equals 4, it's 2. When I equals 5, it's 2. When I equals 6, it's 2. It's always the same value. We have to account for it 6 times because of summation. So that just means this value is equal to 12. So the last part of this video, just going to give you some properties of summations. We're not really going to work any problems with it. It's just kind of for your benefit so you know. And they're fairly straightforward. You could probably put them on your cheat sheet if you want. Maybe just kind of, look them over for the final exam. Again, I wouldn't spend a lot of time memorizing these because they're straightforward what you have to do. The first is if we have k equals 1 to n, we have an ak plus bk. Well, because this is addition, we can basically separate these. We can order the addition any way we want. So this is the same as if I have k equals 1 to n of ak plus k equals 1 to n of bk. I could just add up all the a values, add up all the b values, and then add those two together. We'll get the same answer. 2. So if I have the difference, so if I have k is equal to 1 to n of ak minus bk, again I can split it up. K is 1 to n of ak minus now k equals 1 to n of bk. And then lastly is if I have a scalar. So if k is 1 to n of some value c times this function ak, this is the same as if I just bring the c out, basically factor it out, and then have k equals 1 to n of ak. So So again, we're not going to work example of those. It's just properties, just something to remember. If you have a couple summations and you have to add them together, you could just do them separately and then either add them at the end or subtract them at the end or multiply by a scalar if you needed to. So that's it. That's the end of video 2 for section 12.1. Come on back and we'll look at section 12.2.